Alright guys, last video of the day. I think I might have not done these in the best order, but that's okay. You're still going to have all three of them at the same time. So this one is rational and irrational numbers. Okay? Biggest distinguisher between the two. This word rational has a real big keyword right here. Ratio. Okay? If you can write your number as a ratio or as a fraction, it is a rational number. If you cannot, it is irrational. Write it as a fraction, can't write it as a fraction. So I'm going to show you some examples of that. If I were to write just a whole number, 8. Technically, 8 over 1 is still 8, but it is also now represented as a ratio or as a fraction. Okay? We can also talk about the fact that I could write it as 8.0, which is a terminating decimal, which is a skill you should have learned a couple years ago. So terminating decimal. Okay? The decimal ends. It's at 0. That also is a definer for it being a rational number. All right, let's talk about this decimal. 0.333333. That is what we call a repeating decimal. It goes on and on and on, and it follows the same pattern. You'll sometimes see them written like this with that repeating bar over it. Okay. Those repeating decimals have patterns to them. They can also be written as, you guessed it, a fraction. So again, if I can write it as a fraction, that makes it a rational number. Okay? If we can write it as a fraction, it is rational. Some other things you might see. Something like this. Square root of 49. I left this number line up here for us from one of our other videos because I think it's helpful. 49 is one of our perfect squares. So when I take the square root of it, my answer is 7. 7 is a nice, neat whole number that I can also write as a fraction. It's also terminating. Okay? That is a rational number because I can write it as a fraction. Okay? All right. Irrational numbers are going to be numbers that we cannot write as fractions, that do not have patterns to them. Okay? For example, irrational. 0.32978199273. That number makes no sense. There's no pattern to it. It doesn't repeat itself. If I were to plug this into a calculator and try and get it to write a fraction for me, it would not be able to do it. Okay? It cannot be written as a fraction. That makes it an irrational number. Okay? Another example of irrational numbers that you should be familiar with is the pi symbol. Or pi as a number, I'm sorry. So if you ever see this symbol, know that that represents an irrational number. That number is 3.1429, on and on and on and on and on. Just keeps going. All right? They've never found the end of it. They've gotten all the way out to like 1 million digits, and there's no pattern to it. It doesn't make sense. It's irrational. All right, last type of numbers I want to talk to you about is when we see square roots of a number that is not a perfect square. For example, if I look up on my perfect square number line, the number 60 is not on there. It's in between these two. That means that when I take the square root of 60, it is going to be a decimal that goes on and on forever, and it's not going to repeat itself. that is an irrational number because it's not one of our perfect squares. Another example could be like the negative square root of 12. 12 is not one of our perfect squares. So when I take the square root of 12, I'm going to get some crazy decimal that doesn't make any sense and doesn't have a pattern to it. Okay? So, for example, here we go. Do some practice. I'm going to put up a set of numbers and we're going to try and figure out which one is irrational. Square root of 102. And again, we're looking for rational. Square root of 102. Square root of 25. Square root of 34. Or pi. Now, I already told you about pi. Pi is an irrational number that does not make any sense at all. It's 3.141 something 5962 something something something. Okay? It's irrational. Cross it off. Do we see 34 up here on our perfect squares? I see 36. I don't see a 34. That's irrational. What about 25? The square root of 25 is 5. 5 is a rational number. It is a terminating decimal that can be written as a fraction. If we want to eliminate this last one, 11 would be our next number up here. 11 squared is 121. So 102 is not on my number line. That means the square root of 102 is irrational. All right. Alrighty. I'm going to throw another example up here. This time, instead of looking for rational, we're going to look for an irrational. So here we go. Which one of these numbers is most likely irrational? All right, here we go. Negative 7.9333333, so on and so on. Negative 2.8000000, on and on and on. 4.279458105. Or 5.2626262626. Which one of those do you think is irrational? So let's think about some of the things we talked about. Terminating and repeating decimals are going to be the two most important parts to look at in a problem like this. We want to look for patterns. If we can find patterns, excuse me, if we can find patterns, what that tells us is that it can be written as a fraction if we can find those patterns. So if I look at this first one right here, what you should notice is that these threes repeat and repeat and repeat and repeat and repeat and repeat and repeat. And they just keep going. That means I could write this as negative 7.93, and the 3 repeats itself. I can write that as a fraction. All right. If we look down here at the bottom, 5.2626262626. That is a repeating decimal. I could write it 5.26 with the repeating sign above the 2 and the 6 because they repeat. All right, that is a repeating decimal, which means I can write it as a fraction. Now, here's where we get interesting. We're down to 2 options. These zeros right here. What that means is that when I was writing this number ended right here. These zeros are just what we call placeholders. I don't need them. They're placeholders. So what that means is that I could write that number. It's a terminating decimal. And I could just write it as negative 2.8. That is a rational number. I can write that as a fraction. So that leaves us with this guy right here. It's kind of a hot mess. Okay? There's no pattern to it. There's no rhyme or reason. It doesn't terminate. It just goes on and on and on with no pattern to it at all. That is an irrational number. All right. So I hope these videos help you out. Good luck on your study island. Reach out to any of your wonderful math teachers if you need any more help. Thanks, guys.